Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. So today we're going to discuss on chapter 8, which is the last chapter for this subject. So we're going to discuss on communication system and its applications. So there's a lot of application for the communication system that we learned before in other chapter. So first we're going to look at the terrestrial broadcasting system. So for terrestrial broadcasting system, which is the television broadcasting system, there are two types, analog and digital. So right now we already convert all our broadcasting system to digital. So terrestrial digital TV broadcasting is a new format of broadcasting that enables the viewer to receive high quality video and audio signal than conventional analog TV with no ghost image and no noise. So let's look into the history of Malaysian TV broadcasting. So the black and white analog TV for terrestrial broadcasting started in 1963 by RTM, Radio Television Malaysia. And then 1978, RTM and TV3 introduced color analog TV. So it means around 15 years the TV is black and white, so until 1978. And then in 2010 all the television provider convert the analog TV to the digital television. So between that there's another digital TV broadcasting through satellite, which is introduced by Astro in 1996. So they are different between terrestrial TV broadcasting and satellite TV broadcasting. TV broadcasting, a house needs a receiver and a specific antenna to receive the signal from satellite, and the signal is digital. So that's why Astro has a better quality video and audio compared to the analog TV broadcasting, terrestrial broadcasting. However, if you compare with the terrestrial TV broadcasting right now with the Astro, so it should be similar because both of them is using digital television broadcasting. So this is just a comparison between analog and digital terrestrial television broadcasting. So for analog terrestrial television, it uses analog transmission and receive using antenna at the receiving point, which is at your house. So the quality of the video and audio is a bit lower compared to digital. So for digital terrestrial television, it uses digital transmission 0 and 1, and at the receiving side, which is at your house, it needs a decoder to receive and convert the signal, and the quality of the audio and video is much better than analog. So SKMM, or Suruhanjaya Komunikasi and Multimedia Malaysia, is the regulatory body which regulate and license the broadcasting frequency. So the SKMM not only regulate broadcasting sector, it also regulates others like cellular and also satellite. The figure shows in this slide is the location of the main transmitter for the digital terrestrial television broadcasting. So in Johor, there are 5 transmitters. There's in Gunung Ledang and in Gunung Pulai, and others in Mersing and few more in Johor Bahru area. So Johor Bahru area has a lot of transmitter because there's a lot of small hill that block the main transmitter in Gunung Pulai. In Malaysia, the digital terrestrial television broadcasting uses frequency from 470 to 582 megahertz. So this is the frequency and the bandwidth for operating the digital terrestrial television broadcasting in UHF band, and also another UHF band in band 5. This is band 4, this is band 5, from 582 to 798 megahertz. So all this frequency you need to apply license to use it from MCMC or SKMM. So MCMC is in English term, Malaysian Communication and Multimedia Commission. So right now the main service is more on one-way communication, which is broadcasting, watching TV and so on. But in the future, it is expected that this broadcasting system will also will embed internet connection. So means that you can surf the internet through your television in the future. So this is the technical operation of the this is an example of the technical operation for the digital terrestrial television broadcasting. For example, on your left side is where the programs recorded, for example live football, or might be recorded program in studio. So let's look into this live broadcast first. So it uses OB van or outdoor broadcasting van to record a football match, for example, and it will transmit the data, the live football match through satellites, and then send it back to the headquarters, which is the center of the broadcasting. And from here, it will go to the post-processing of the program, and then goes to the transmitter to transmit to the user or the. So let's look into the advantages of the digital terrestrial television broadcasting. So first, analog produce weak signal which cause snowy picture, similar like this figure here. However, in digital it produce clear picture, although it receive a lower signal level. So for analog multipath reflection from tall building cause ghosting. Ghosting means that a double image appear in a video. We call it ghosting. However, using digital, we can get clear picture and no ghosting because there's a decoder and they have the what we call error correction. So DTT or digital terrestrial television support high definition television. For digital TV, we can support up to 1080 times 1920 pixel compared to the analogs. Can goes up to only 575 times 720 pixel. Other than that, digital terrestrial television support reception by mobile or portable device. For analog, you can only receive the fixed reception only, but digital, if you are in a car or in a bus or using your phone, you can still receive the broadcast. So why developed countries are changing analog to digital terrestrial broadcasting? First is the capacity required are increasing. More programs and service require high data rate. Digital broadcast service can consist a number of elements: the core audiovisual element, data element, electronic program, guide, EPG, and possible third-party applications such as social media. So that's why, because of the capacity is increasing, that's why they change it to the digital terrestrial broadcasting. So broadcaster wants to deliver linear and nonlinear service to customer device that do not come with broadcast tuner. For example, there are consumer that want to use laptop or mobile phone. Let's look into the difference between terrestrial TV and satellite TV. So for terrestrial TV, it is earthbound compared to satellite TV, which is the satellite is at the outer space. The terrestrial TV broadcasts from antenna tower on Earth, while satellite TV broadcasts uses satellite in the sky, which is at the orbit. So for terrestrial TV, there are specific coverage range area, which is not as large as satellite TV. So satellite might cover half of the continent or might cover the whole Malaysia for one satellite compared to terrestrial TV. For terrestrial TV, the broadcast signal is sent to the various towers, and if you are within the area covered by the tower, then you will be able to receive the broadcast service via a terrestrial aerial, which is usually placed on your roof or on your television set, depending on how strong the signal that you are receiving it at. While the satellite TV, the broadcast signal is sent to the satellite and the signal is received via a satellite dish. For example, Astro. So this is the antenna for Astro system. So if you look at this, there's a reflector which reflects the signal from the satellite from the sky and then bounce back into a receiver here. So this receiver is called LNB, low noise block, which consists of LNA and mixer. So LNA is low noise amplifier, which amplify the signal reflected by the reflector here, and the mixer will downscale the frequency from few gigahertz to megahertz range, so that it can travel in the wave can travel into this cable without with low loss. So satellite broadcasting usually operate in Ku band from 14 to 14.5 GHz in uplink frequency and 10.95 to 12.75 GHz for the downlink frequency usage. So if you look at this picture, this is the gateway, which is the Astro headquarters, and it will send the broadcast signal, television signal, to the satellite, and this satellite is like a reflector or relay that bounce back all the signal from sent by the HQ to the user. So this is our house, so everyone can get the broadcast signal. So why using satellite? First is the bandwidth. So satellite network offer broadband link. So bandwidth independent from the number of user for broadcast and multicast transmission. And another one is coverage. So satellite coverage enable the international and intercontinental extension of the network overcoming. So it overcome geological constraint and poor terrestrial infrastructure. So that's why if you are living far away from the city in the rural area, so you still can watch television if you're using satellite system. So other than satellite broadcasting, there are other applications for the satellite. For example, satellite phone. So it provides uh, telecommunication connection, phone connection through satellite throughout the globe, throughout the world. So for this system, it requires 66 satellites, which cover the whole world here. For example, this one. So this satellite is at the low Earth orbit, which is closer to the Earth. Other than that is the in-flight Wi-Fi that provided by AirAsia. So AirAsia provide an in-flight Wi-Fi in all their flights. So how actually they get the connection, the internet connection? It's basically from the satellite. So for example, there's a TMHQ here provide internet connection through satellite uh, and connected to the airplane. So on top of the airplane there are antenna placed which pointed to the satellite for connection. Other than that, there's a company called Starlink, which founded by Elon Musk. So this Starlink is a satellite internet constellation being constructed by SpaceX, providing satellite internet access. So this it uses around 96 satellites to cover the whole globe or the whole world and it provides internet access anywhere. So for this satellite, it uses low Earth orbit LEO satellite orbit. Other than that, navigation is also using satellites. So for example, if you're using Google Map or Waze through your phone, so basically your phone is receiving a satellite signal to coordinate the position of your the position or the current position you are at. So not only for vehicle, it also used for the uh, airplane and also ship to for navigation. So um, for satellite navigation, it uses geo satellite. Geo is geostationary Earth orbit satellite. So this satellite is the farthest satellite from the Earth, which around 40,000 kilometers from the surface of the Earth, and it rotates. The speed of the rotation of the speed of the satellite is similar to the speed of the rotation of the Earth. So it's look like that the satellite is not moving. So it's not moving or static at the Earth surface. So there are Few advantages of geosynchronous or geostationary satellite. First, it remains almost stationary in respect to a given Earth station. And then geosatellites are available to all Earth stations within their shadow 100% of the time. The shadow of a satellite include all Earth stations that have a line of sight path to it and lie within the radiation pattern of the satellite antennas. There is no need to switch from one geosynchronized satellite to another as they are orbit overhead. Consequently, there are no transmission break due to switching time. So for geostationary satellite, it requires at least 3 satellites to cover the whole globes. Because this satellite is located farthest away from the far away from the Earth. So the geostationary or geosynchronous satellite has few disadvantages. First, geostationary satellite requires sophisticated and heavy propulsion device on board to keep them in a fixed orbit. Second is high altitude geostationary satellite introduce much longer propagation delay. The round-trip propagation delay between 500 milliseconds to 600 milliseconds. So that's why geostationary satellite is not used for internet or telecommunication connection because of the delay is too high. So all the internet or telecommunication satellite is placed or located in the near or low Earth orbit of the Earth. So geostationary satellite require high transmit power and more sensitive receiver because of the longer distance and greater path loss, and high precision spacemanship is required to place a geosynchronized or geostationary satellite into orbit and to keep it there.